Hi guys, so we're going to continue talking about forces, but we're going to focus in on just a few of them. But before we do, I want you to think back to what the four fundamental forces are. So pause the tutorial and see how many of those four fundamental forces you can remember. I'll give you a big hint. One of them is gravity. So the four fundamental forces are gravity, electromagnetism, the strong force, and the weak force. But we don't really discuss the strong and weak force in detail. We're going to touch on them. So most of the forces that we deal with are either gravity or electromagnetism. So let's make a free body diagram for this balloon car that's hanging out in my kitchen inexplicably. I have the balloon car moving to the right, so the applied force is greater than the friction force. Think about the forces that are acting on this balloon car and ask yourself, are these forces fundamentally gravity or electromagnetism? Strong and weak forces are only happening inside of atoms, and so you don't want to worry about that yet. Just figure out, of these forces that you're seeing here, which one of them are the gravity force and which one of them are the electromagnetic force. Okay, so if you've done that, then you'll see that gravity only shows up in one place. Not surprisingly, down here pointing towards the ground. Then electromagnetism is everywhere else. Think about it. The normal force is the electromagnetic force of the atoms in this table pushing up on the wheels of this car. And then the applied force is the atoms in the air pushing on the atoms in the balloon. The friction force is the atoms of the table pushing against the atoms in the wheels. And what we want to do now is figure out exactly what is that push caused by. So electromagnetism is a force between charges, and it can either attract or repel, depending on what the charges are. So atoms are where these charges are found. So what I have here are two atoms that are right next to each other, and you'll see that there are negative and positive charges. The protons, which are found in the nucleus of the atom, actually have a positive charge right here. So the protons are positively charged. And then the electrons are negatively charged, and they're way out here in the outer part of the atom. There's also something called the neutron, which you can hear the word neutral in there. Neutrons have no charge because they're neutral. We'll talk about why they're there later. So the electromagnetic force that holds an atom together is the attraction between this negatively charged particle and the positively charged particle. So this atom, you'll notice, has 3 protons, 3 positively charged particles, and it attracts 3 negatively charged particles. They don't actually collide with this nucleus because they're moving really, really fast, so they have their own inertia that makes them keep moving. Then we also have not only the force that holds the atom together, but another force that pushes atoms apart. You'll notice that if this negatively charged electron comes near this negatively charged electron from the other atom, there could actually be a repulsive force they could push apart. Now, it's a lot more complicated than that. But essentially, what it comes down to is an electromagnetic force is either a push or a pull between charges that are opposite each other, like these two, negative charge and positive charge. They're attracted to each other. Or they're pushed apart because they're like charges, like these two. Now, if you're really a smarty pants, you're wondering, wait a minute, here's a positive charge, and right next to it is another positive charge. How come they're not flying apart? The answer? That's the strong force. We don't talk about it in this class because it's really complicated. But basically, there's a force that's really, really strong, but only happens in a space as tiny as the nucleus of an atom. So that strong force can only happen when these two things get this close, and that's why they're able to stick together like they're stuck together with glue. So now you might be thinking, well, Mrs. Straguzzi, if this electron and this electron are near each other, how come these two atoms don't just push apart? And how come all the atoms in the universe don't just push apart from each other? That obviously isn't happening, right? Obviously, things stick together. You have multiple atoms in all the objects around you. So there must be something else that's going on. That something else is something we'll talk about in our chemistry unit to explain how two atoms that seemingly should not want to be together because of this repulsion do actually hook together. For now, all you care about is that if the electrons of one atom get near the electrons of another, they can repel each other. They can push each other apart. Okay, to sum this up, let's go back to our balloon car and remember that the forces that aren't gravity, all these guys, this one over here, the friction force, the normal force, and the applied force, all of those are actually electromagnetism. So I want to think about what that means. So what that literally means is that down here where the wheels meet the table, these wheels are made of atoms. Those atoms have electrons in the outer part of them, and those electrons repel the electrons in the outer part of the table's atoms. So they push against each other. They repel each other, which is why this balloon car is being held up against gravity. That's the normal force. The normal force is the push that the table's atoms give to the car's atoms. The same thing is true for the friction force and for the applied force. If you stop and think about it, and I invite you to do that, you'll realize that it's one type of atom pushing off against another type of atom. And that's really the basics of electromagnetism. So now in class, we're going to expand on this information to talk a little more about electromagnetism, and then we're going to talk in more detail about gravity, which we talked a little bit about, and we might touch a little more on the strong force. So make sure that you fill out your graphic organizer and come to class prepared to have that discussion. See you then.